Hello friends of the net, I'm Landworth and you can find me on Twitter at TerraJobs. So in this episode we're going to implement nullable reference types in our compiler code base, and to just lower your expectations, we're not actually building a feature for a language that allows us to express nullable reference types, but we will annotate our C# compiler code base with nullable reference types. So in other words, this is actually something we can actually do in 2 hours rather than spending the next 3 months trying to come up with language semantics and syntax and all the other things that come with that. So if you're here to learn how to implement nullable reference types in your own compiler, I'm sorry I have to disappoint, but if you're here to learn how to use nullable reference types in your own code base, and you also happen to like compilers, then this is the episode that is for you. Welcome to all the people in the chat. I can see there's quite a few of you, so make sure to ask questions, and hopefully I'm doing a good job of answering them. I think I've become better now that I have multiple monitors. I actually can pay more attention to the chat, which if you're on a single monitor is actually somewhat challenging. So let's just jump in. So first we will look at our PRs again, and I will again close Telegram, which I keep forgetting. All right, so yeah, I've been a bad boy. I still haven't merged the trivia episode. Apparently, now that I'm streaming twice a week, it's hard for me to finish one thing before the other, but it's fine. The notes are almost halfway done, so I don't worry about it too much. Let's look at this one here. So I still have not reviewed this one here, which again, I should have done that. Let's take this one first here, because I think this is hopefully an easy one. Interesting. So this one is, I don't think, an easy one, because introducing warnings and errors in the compiler is, given that we don't have that distinction today, I haven't even thought about it myself yet, how this would work. Yeah, I think this is one thing that I actually have to review offline, because I have to develop my own viewpoint on what I want this separation to look like before I can even decide whether I will take this or not. I'm sorry for that, but that's just sometimes the way it is. So I think this one, I had a brief look at it. Yeah, lots of discussion on this one. This is a general interesting discussion that we have right now with the Roslyn team. So if you just look at the code here, there's a lot of busy work going on here, right? And we have simplified this to a certain extent by using the indented text writer from the .NET platform, because it allows us at least to do indent rather than actually making sure that we have to have the right indents here. But there's still a lot of busy work involved, and some stuff is harder than it probably should have been. Like, for example, you have to manually add usings and stuff. And so there's some interesting ideas on the Roslyn team on how to make this easier. So there aren't really any super easy answers. So whatever we do here in this space is, or I consider at least, somewhat temporary until the Roslyn team has a slightly better API than just saying, give me the string somehow. And yeah, we don't really have that yet. Which also means that I don't really have a viewpoint yet either on how things should be. But I think this one seems to be making at least the improvement that we can no longer have to deal with curlies. But I'm not sure I want this thing to be curly indenter, because I suspect that what I would want from this guy is also some sort of basic syntax handling, so that I can, I don't know, maybe just call a method called write type and I give it an I type symbol, and then for example the using gets automatically written for me, or something to that extent, right? Or maybe even have methods like add using, where you only have to provide this name here and then the rest is done for you. So just to reduce the clutter that this type has. But again, I think that's something I need to do offline because I'm still not entirely sure where I want this to go. And then the build infrastructure one, I know it's a lot of changes, but I haven't taken a look yet. So I think on the weekend I will spend some time on this, and then next week we can hopefully merge some stuff. That's the downside when the PRs you're getting are getting also more involved. See, let's not spill the coffee. Lots of friendly names in the chat. Dot Morton is also here. Hey Morton, how's it going? Alrighty, so I think it's time. Let's just start somewhere. Episode, what is it, 25, I think? Let's look at the docs. Yep, 24 is still in progress. And then we'll have some fun today. So, for nullable reference types, what's the approach? Well, we can do one of two things. We can either, first of all, let's talk about our language here. So we are using the preview version of C#, which is fine because it basically means we have access to the latest version. So we should be able to just use nullable reference types. We just have to specify that we want to use it, which is, I think, and I remember correctly, nullable enable. And if I did everything right, then I will get a ton of warnings right now. But we'll find out. Won't adding nullable reference types break those PRs? Maybe. I mean, that kind of depends. I don't think there will be merge conflicts that are that bad because hopefully we can isolate these changes somehow. But we'll see. I mean, that's the downside. I agree with that, but I'm not willing to just happily merge all the PRs. Yeah, so this is fine. So we have, what do we have? 96 warnings. I think most of them, I mean, I did already a pass over that where I experimented with this. I don't think it will be that bad. But it's a good point. In real code bases, there can be a lot of churn because of it, which is now also the question how we want to deal with that. One way we can do this is saying, instead of now continuing, we just first mark all the types as nullable, enable, false, which now allows us to effectively selectively decide which files we want to opt in. So in other words, instead of doing this, we can do this. Which basically means we opt in each file. Unfortunately, that opting in part is not great because if people add new files to the code base, they will always start with nullable disable. So instead of doing that, we will do the opposite. We will opt files out rather than opting files in. So basically we do this on top of all files, which is kind of annoying, which is also why I don't bother in this code base right now, but that's basically the preferred approach. And if your code base is large enough, which most are, it's not super hard to just, write yourself a very simple shell script that just puts this thing on top of each file, right? Which, again, I don't care for right now. I just go with the Big Bang approach, but I will do the Big Bang approach on a per project basis so that I'm not entirely killing myself in the process here. So, oopsie. And then hopefully I have some sane approach to this. if it builds, ship it. Yeah, and I mean that's kind of the goal, right? I want to leave this in a state today where things make sense. Now you can see already I have a lot of warnings that I now get because I upped the entire project in. But I think for my case, that's kind of where I want to go with this. So the way I want to deal with that is I want to kind of work my layers outwards. So if you think of our compiler layer, there is effectively multiple parts here. Syntax is kind of the lowest layer. I mean, probably text is the lowest layer. So we can, I guess, let's open the text layer first and decide what we want to do here. So text span is simple, right? There's no strings here, no reference types here, so we can close this because this file is already correctly annotated by not annotating anything. Text line. So we have a source text, which, yep, is not nullable, or shouldn't be null. So that is correctly annotated. Yep. So toString in our case will not return anything nullable. So it's also correctly annotated. So text location. So source text, yep. This is a value type, also fine. File name. So file name is the first one where we probably have to think about it. Will we always have a file name? And I think the answer is yes. And for strings, it might actually be easier to say if there is no file name, you just return an empty string rather than null. So I think this is also correctly annotated. All right, source text. So can the text be null? No. Can the file name be null? I don't think we want it to be null, because the default value is empty string already. So that means parse lines can't be null. And then here the privates also seem, generally speaking, correct. The other benefit of putting nullable disable at the top of each file is you know which file you already reviewed. And that also makes it easier for you to keep track of what's going on. All right, lines. This one is fine. Yeah, this all seems fine. So I think I convinced myself that text is correctly annotated by the lack of annotations, right? So one of the things in C# there was a discussion is, should C# have syntax for saying something is null, or should C# have syntax for things that are non-null? And when I was in the meetings that we discussed this, I said, like, I strongly feel I don't want to have the expression for what is null, what is not null, because practically speaking, the vast majority of reference types you're using, you don't expect them to be null. So you want to annotate less. That's one thing. The second thing is we already have nullable annotations in the language of nullable value types. So it seemed weird to introduce the opposite notion for reference types. So just as a quick sidecar. So now let's actually look at all of these guys. So let me open up all the syntax nodes and then let's walk them. And for the syntax nodes, I think there will definitely be cases where things can be null. And if you followed the previous episodes, you have seen me struggle with not remembering what I decided that can be null. So this is going to be fun. All right, let's just walk this in whatever order they are now open. So while statement, syntax tree, while condition, body. So all of these things will be required, so that one is fine. Variable declaration, syntax tree, keyword, identifier, type clause. So here's already parts that are optional, right? So the type clause is optional, right? You don't have to specify type, we can infer types. So that means this one would be question mark. And in our language, we do require initializers for variables. So that means these guys are required indeed. And so now we can say, all right, the type clause syntax is optional, so this is nullable. And the rest is all required. Unary expression. Yep, everything here is required. Type clause. Same thing. Everything in here is required. If you have a type clause, you must specify colon, you must specify the identifier. So in that sense, the whole type clause might be not, but if there is a type clause, all things are required. Syntax token, tree, kind, position, text, value. So the value can definitely be null. Aha. So here's an interesting one. If a token is inserted by the parser and doesn't appear in source, we're saying text can be null. So something tells me I'm using text a lot. Yeah, 30 results in 4 files. Sorry, in 5 files. Speaking is hard, apparently. So I don't think I want to make, I mean, I could make text nullable, but I don't think I want. So the reason I'm saying this is, you know, do I have 30 bucks in my code right now? Not very likely. However, the problem is that our compiler won't be smart enough to detect that all of these usages here are guaranteed to be non-null. So if I go with this design where I say text is nullable, I will very likely have to either suppress a lot of warnings that I might dereference a null value, because by looking at the code, you know that this never can be null. Because for example, let's say I have code that says if token is not missing, do something. Well, if the token is not missing, I know that that means that text is not null, but I can't express that. And so that would mean that, you know, things are going in the way that I don't want. So what I would rather do is, I think I will change this thing here. Either I can cheat in the constructor and I can say, well, if you give me a value here that is null, so I would mark this guy here as nullable. But then when I assign it, I could say, if you give me null value, I just assign empty. Which is probably the semantics that I want. So we consider the semantics that if text is null, is missing is true, but instead of doing this by computation, we could just say, well, we remember whether you gave me a null text, which might be easier for our code base to deal with. And that means this guy can never be null. And then this guy can never be null either. Yeah, I think that's what I want to do. Instead of nullable, does it make sense to bring in the concept of options and try to leverage the newer pattern matching features in C#? Yeah, no. I mean, I understand the appeal if you're coming from F# to use options instead of null. It just, in C# it doesn't feel very natural. And there is certainly some overhead involved with dealing with that, because you effectively have to wrap every reference type with effectively something that is not every reference type, but everything that can be null with another type that effectively carries the pointer of the reference type plus an int, right? And so you significantly increase the size of your representation, versus these guys here are just annotations in the code base. So yeah, I'm not going to do that. And as Frederick pointed out, even if you go with option, you're basically doing the exact same thing that we're doing right now, right? You just change the way you express whether something can be null or not. And whether you do this by an is null check, or whether you check the option against none versus present. It's kind of the same thing. But in F Sharp, I mean, I'm not an expert in F Sharp, but based on what people who do F Sharp tell me is that options feel more natural in F Sharp than null values. And I guess in C Sharp, I would say the opposite is true, right? In C Sharp, comparing to null is a pretty common operation. And it's also very common to forget it. And you could argue that because F Sharp has pattern matching and completion checking, that is more, more natural. But I don't know. I remain unconvinced that this is the right design for us. All right, so let's go with this for now. That seems reasonable. I'll probably regret that choice later. Syntax no. So what can be null here? So the syntax tree can't be null. Yeah, so here's an interesting thing. As you might remember from the last time, we have a bug now where our generator will effectively create nodes that are null because we don't check in the generated getChildren method. But I think the intent is that this guy will never give you a syntax node that is null. So this one is correctly annotated. And we will change the generator to honor that. So getChildren last, get last token. Yeah, so this one should always be well defined. So we should always return one. Right to, we always have one. Syntax no, we always have one. So that's fine. So this one also seems correctly annotated. Statement syntax, not much to do. Separated syntax list. Yeah, we take a bunch of syntax nodes. None of them can be null. And then here's an interesting one, right? So get separator. Well, we give you an index. And if the index is in between two things, we return you the one. If you give me the last element, then there's no separator, so we return null. So that's a great example where you have to decide what you want your API to do. We could also say, instead of doing this, right, we could say we do this. We say, okay, there can always be null, in which case this is fine, right? But now code gets a bit more weird. So the other way we could do it, we could say, well, if index is this one, then we just throw an index out of range exception. Right? Or argument index out of range. What is it? Argument out of range, right? Oh, I guess I don't have a using for system. Yes, that's why. Which I think makes more sense, because otherwise the problem with that approach is you penalize everybody, even people that give you correct indices for checking. But if you're really sure that you always have an index, you might as well throw an exception here. But this goes back to this whole problem with nullable reference types, is that there really isn't this thing called correct. And so you need to basically decide what is the design approach you want to promote, and what seems tasteful for your API, right? So there's basically an element of taste involved when you design your APIs with nullable reference types in mind. Which in my case here, I think this is more tasteful than saying the separator might be null, in my opinion. And in fact, we could probably also simplify this here, and we say if the index is less than 0, or index is this, then it's out of range, right? Which arguably is something we should do anyways. All right, so then I claim this one is annotated correctly. Return statement syntax. So here's another fun one. So return statements, the expression is optional, right? So that's clearly an example where this should be marked as nullable. Parenthesized expression. Yeah, everything here is required. And again, let's remember that when the way our parser works is when things are required but you didn't pass them in, the parser will manufacture them, right? So if you, for example, forget the close parenthesis, the parser will generate a close parenthesis token and fill it in. And that is precisely to avoid null references for code later, right? And you can tell whether something was inserted by the parser by asking the token whether it was missing. But this basically avoids this problem where you write a printy printer and now basically you would have to check every single thing in the node for being potentially null. And so this is the idea here. So these guys are all required. All fine. Parameter syntax. Yes, identifier and type are both required. Name expression. Okay, we need the name, so that is clearly required. Member syntax, not much to do. Literal expression. Okay, so here we go. Literal expression. Yeah, so we basically can construct this either but from a literal token or from when we have a value. How does that work? Who's doing that? The parser does that. When we, oh yeah, so the parser does that when we construct a Boolean literal, because it's a keyword. But we're saying the value is based on whether this thing is there or not. Okay, that makes sense. And then this guy is basically saying, well, if you gave me a literal token, it must have a value, right? Otherwise, something bad has happened in our definition of the language, because either the legs are messed up or the parser messed up. So, sorry, here we know that this guy can't be null, right? Because if the syntax kind from the token was a literal, that's the only place where the parser would have called this API. So right now these are all public APIs. They shouldn't be public. They should be internal. We should not allow third parties to construct arbitrary syntax nodes. That's a bug we should fix too. But you know, from the purpose of this API, this is fine. So this can't be null, and this cannot be not null. So that's fine. So basically, what this exclamation mark is saying is, yeah, you don't know this is not null, but dear compiler, I know this expression here to the left of the bang is not null at runtime. And so the compiler doesn't do anything here, so there's no code being emitted. It just means if this happens to be null, yep, the compiler will call this method with a null, and then, you know, bad things might happen to your program. All right, so then let's close this guy. Let's ignore the parser for now. If statement. Okay, so we have an if keyword, a condition, a then statement, and an else clause. So again, in an if statement case, the else is optional, right? You don't have to have an else clause. So we will mark the entire else clause as optional. But the if keyword, the condition, and the statement are all required. Yeah, so that's the general problem with C#, or with, I guess, the CLR, if you will, is that there is no such thing as a guaranteed runtime not null, right? And people say, well, we could change the runtime. Yes, in principle, you could change the runtime. In practice, it's not that easy, because the thing is, in order to really make sure that nulls can't be observed unless you did something, would require effectively a certain amount of runtime checks to be embedded in your code, which are not free, right? They cost money in terms of execution speed and other things, right? And you know, same is true with arrays and bounce checking, right? Bounce checking is not free. You can't statically verify that your indexers are always within the bounds, right? That's just not feasible, which is why the CLR has bounce checks that are done at runtime. And the JIT tries really, really hard to detect, you know, canonical for loops so that the JIT can know when, you know, you don't have to do bounce checks because the runtime guarantees that the thing is within the bounds. But it's hard, and there are also cases where we just can't. So you actually pay the penalty at runtime for bounce checks in some cases. And again, in the general vicinity of, depending on whether you have a hot loop or not, it probably doesn't even register on your perf radar, right? But if you don't think about nulls, you pass things a lot, right? And so there would definitely be a sort of, you know, issue with code size when you emit all these, you know, extra null checks everywhere. And that's why we basically said, like, okay, in order to make this feature viable, we either can decide that we don't tackle nulls at all, which is the last 20 years, or we're going with a design where we make it so that in the language you can express what things are not null. And the language does its best to statically give you warnings when it knows for a fact based on your notations you're not consistent, right? Does this catch all cases? No. Can you lie? Absolutely, we just did. And so that means you can still observe null references for things you said cannot be null, right? That's a thing that can happen. But I personally, after using this feature, I'm actually convinced that this is still adding a ton of value, because at least I can express what's null, right? And in the syntax trees, for example, it makes total sense for me to say, yeah, this member here can be null. So if you do reference it, please compare it against null, right? And we will see later that this is actually useful. But yeah, it's not bulletproof. All right, global statement syntax statement is required in this case. Function declaration. All right, so what do we have here? We have a syntax token with a function keyword, identifier, open parenthesis token, parameters, close parenthesis token, type clause. And as I said, the type clause is optional because we have procedures, right, which are functions that don't return anything. And then we have a block statement syntax. All right, that makes sense. So that means the only thing here optional is type. For statement. What do we have? Keyword, identifier equals lower bound to upper bound body. They're all required. So that looks right. Expression syntax. Not much to do. Expression statement takes an expression. Yep, that looks good. Else clause, else keyword, else statement, both required. Do while, we have do body while condition, they're all required. Continuation, yeah, continue statement, yep, only has a continue keyword, that's fine. Compilation unit syntax has an array of members, an end of file token, and they're both required. Call expression has an identifier, open parenthesis, close arguments, close parenthesis, they're all required as well. Break is just a break keyword. Block statement is open brace, statements, close brace, so they're all required as well. Binary, left, operator right, yep, doesn't get much simpler than that. Assignment is the thing we want to assign to, equal sign expression, they're all required as well. So, okay, so now that means syntax nodes, I'm feeling good about myself that I've annotated them correctly. Now let's look at the code that actually does something. So let's start with the lexer. And we're already off to a good start, right? So the constructor already gets flagged. Non-nullable field value is uninitialized. Consider declaring the field as nullable. Yes, so these are the things that we effectively keep track of per token. So yes, of course, value can be null. So this is actually a thing that we should mark as nullable. And that's it, really. All warnings already disappeared. That's convenient. All right, parser. All right, pass optional type clause. As the name suggests, this should be nullable. Pass else clause. Well, first of all, probably should do that, right? Just to be consistent with our own naming here. So that means parser is now fine as well. All right, so I don't know whether you can see this on the stream, but there's color coding here that tells me where warnings are. So this light yellow is modified files, and then this darker yellow is warnings. So I'll try to fix those next. So one problem with nullable reference types is why we basically tell people like may consider putting the suppression on all the files, is that you will have to frequently go back to files you already edited, right? Because every time you change global annotations, meaning global, type information effectively in your signatures, well, now the files that use those might know additional null checks, right? So that means it's a bit of a convergence issue where you can't quite do things once only. You have to may do it multiple times. All right, so what do we have here? So this is our get text one. So we're basically saying, what is the text for a given syntax kind? Yes, and this can return null. So we should mark this guy as nullable. And now again, everybody who calls get text, which might be files already edited, now have to potentially guard for null here, right? Syntax tree, what's happening here? So what is root? Where's root coming from? It's an out, or this guy here. Yeah, so here's an example of where we may have to lie, because we will guarantee that this guy will be initialized, clearly, because that's an out, we have to initialize it. But it will never have an observable value of null once the method leaves. So does the compiler know that? Maybe? So maybe we just have to remove the annotation here. Yeah, the compiler should be able to tell this, right? Because this loop clearly never terminates. So the only way we can get to this end here is under this if statement. And clearly we assigned the thing before we call break. Well, we don't call break, we break the loop. So that was easy. Sometimes you just get things for free by deleting code. So that means syntax is now annotated, as far as I can tell. I will not do compilation and evaluator yet because they are, you know, high level in our APIs. So the next thing I want to tackle is symbols themselves, which should be fairly straightforward. In literal expression, shouldn't the constructor contain a throwing null coalescing expression instead of suppressing the null reference warning? No. Null coalescing would mean we would, I mean, sure, I know what you mean now. Okay, so if we go to vector literal expression, literal, what he's referring to is this one here. So what we could do, instead of doing this, we could say throw argument null exception, right? But the problem is, or throw argument exception or whatever, right? Because clearly the argument is null. It's a member that is null here. But we generally don't do that in our code base right now. So argument validation is not a thing we care for. Again, these are public APIs. They should do argument validation, but we don't do that right now for most of our stuff, which arguably we should. But again, I'd rather not churn the boat too much. I just want to start with nullable annotations, and then if you want to add validation, that's a separate thing. But arguably, it would be better to have existing existing argument validation in place, because it would allow you to find more bugs as you're progressing. All right, so variable symbol. So we have a name, read-only, type, and constant. So the constant clearly can be null. So type symbol. Okay, that's simple. Nothing here can be null. Okay, that's a big one. Symbol kind, easy. It's an enum. Symbol, name cannot be null. Parameter symbol. Okay, name type ordinal. This I believe is the constant, which we will mark in the base type as null, in which case this warning will disappear. So this seems fine. Local variable. Yep, this guy should take a a nullable constant. Then the rest seems fine. Global variable, same thing, this can be null. Function symbol. So type cannot be null here, because in our symbol representation, when the type was omitted, we use void. So that's fine. Clearly we assign null here, so clearly this guy is nullable. So let's mark it as such. Built-in functions should be pretty straightforward. Yeah. Alright, symbol printer. That's the guy that walks our symbols. And nothing to do here, apparently. Yeah, none of these things can be null in the signatures, and then the code will tell me whether I have some issues, so that's fine. Okay, so now our symbols are right. Now it doesn't really matter which order I walk this, I guess. Lowerer, what are you complaining about? Oh yes, okay, so no, actually it doesn't make a difference, because the next thing we should probably walk is our bound nodes. So let's just open all of those guys up. And again, I've skipped everything that I know is effectively code. Like the binder itself. So let's start with the base types that might actually help our case. So bound node. Yeah, it looks pretty fine. Nothing can be nullable here. Bound expression. Yep, that guy has our virtual constant value, which can be null. Type cannot be null. Maybe let's tackle bound statement next. Yeah, easy, nothing is null. Alright, bound assignment expression. Well, we have a variable we want to assign to, and we have an expression. Neither of them can be null, so that's fine. Bound binary, we have left operator and right. Nothing can be null here either. But we override this guy, and this should be nullable still. So there's another design point in C# that when you override, you get to redeclare the null annotations, and that also means you can change your mind, right? So it makes complete sense to say in the base type it might be null, but then the derived type it can never be null because of the way the type is initialized, right? So omitting null in the annotations in a derived method, or an override to be precise, makes sense. It's actually a sensible thing to do. In fact, you probably do this a lot for toString, because the base definition of toString in the framework is indeed nullable, because, well, we don't know what you're doing. And that was a very controversial decision we made on the team, because there was this trade-off between should we tell overriders what to do, or should we tell consumers that the overrider might have done the wrong thing. And the wrong thing is, again, in the eye of the beholder, because we checked our docs and we looked at the actual real code, and even in our own code base we found plenty of examples where if you call object.toString, it might give you a null value. And so we said, well, we just mark the base type as that, and most of the time when you call object.toString against the object type, you're very likely passing it on to other APIs, like, you know, console.writeline, for example, in which case the framework already has annotated these APIs with accepting null. So you don't actually get a warning for those. Anyway, so yeah, this one makes sense. Constant value is overridden. Bound binary operator. What do we have? Syntax kind, left type. Yeah, they're all required, so nothing should be nullable here. The bind method might give you back a null operator. That makes sense. Ouch. This guy is out of sync here. How did that happen? Okay, this is the enum. Trivial. Bound block statement. Very trivial. Nothing can be null here. Bound call. Yeah, function against some arguments. Nothing can be null here. Bound conditional goto. Yep, nothing can be null here. You need a label, you need the condition, you need to know whether you're jumping. Bound constant. Yep. Again, this might be null if you support null literals. We don't have that right now. So, not null for now. Bound conversion expression. We need the type, we need the expression. So nothing is null here. Bound do while statement. Yes, I think yes, everything here needs to be non-null. Bound loop statement gets a break label and continue label, and they're all required, so nothing is null here. Bound error, simple, nothing is null. Bound expression, well bound statement, expression statement needs clearly an expression, that's fine. Bound 4, we need lower bound, upper bound, variable and body, they're all required. Bound global scope. Yeah, I think those guys are nullable because I don't think we always have one. And then previous is also null, clearly for the first one. So that seems right. Bound goto statement, we need the label. Bound if, condition, then else. Yeah, else is optional. Else is optional. Condition is required. Label, we need a name. Bound label statement, we need a label. Literal expression, yep, we already said this guy cannot be null. In this case, constant value is always going to be set, right? So this guy is actually correctly annotated with not null. Bound node printer, we take this later. Bound knob statement, okay, nothing to do here. Bounds program, okay, clearly this guy can be null because we might not have a previous. We might not have a main, we might not have a script. Bound return statement. Yes, this expression is optional, right? Because you might not return anything. Bound scope. So parent might be null. Clearly, right? Because eventually this thing, I mean, it's a hierarchy, so root clearly doesn't have a parent one. So try lookup symbol would return null potentially, right? So the rest here is annotated correctly. Unary. Yep, we need an operator and operand. Constant value might be null though. Bound unary operator. So these guys are all required, but then this guy, the bind, might give you a null back. Unary kind is an enum, nothing to do. Bound variable. We always have an initializer, so that's all correct. Bound variable expression. Yeah, this guy might of course be null. Because variable might not be constant. The rest is required though. Do while, same thing, condition and body are both required, so that's fine. Alright, so now let's talk about the code parts here. So we have conversion, constant folding, control flow graph, the tree rewriter. Apparently this guy also now has a warning and bound scope. And our favorite one, the binder. Alright, let's see. Bound node printer. This guy has no warnings. Wow, that's that means you have the right null checks in place, right? Because this is the thing you would have expected to have issues in case something is null. But we don't seem to have that. Bound tree rewriter. Okay, so here's our pattern with lazy initialization, so these guys should be null. And then same here, this guy should be marked nullable. Then the rest seems to be fine. Right, so conversion. Type symbol to from, both required. This guy only exposes simple types. So this one is done. Constant folding. Compute constant, yes. So this guy can return a null value. And then same thing here, this guy can also return a null value. But then the arguments themselves cannot be null. So this looks right to me. Bound scope, what are you complaining about now? The dictionary, okay, fine. Yeah, the dictionary is lazy, so let's do that. And then again, compiler is happy with the result, so I'm happy. Control flow graph is probably one of the things with the most code. Okay, this guy can be null clearly. Yeah, so here's an example where our code has issues. So one thing we can do here is instead of us just lying, we can just do this. We can say debug assert okay, what is this guy going? Diagnostics. Yeah, so here's one problem that I have right now. So normally this is supposed to work, right? Because we're saying, well, this guy, so we call this from a place in our compiler where we know that, of course, you have an operator for not bool, right? But of course, this method is typed as returning potentially a null operator. So what I can do is I can just say, okay, this guy is not, like, I know this guy is not null, so I debug asserted. But then the question is, okay, what should happen at runtime, right? And so how does the compiler know that if this thing is basically guaranteed to not continue executing when this guy is not null? And the answer is there's an attribute on that method. But for some reason, the compiler doesn't seem to understand that. And the reason the compiler doesn't understand that is because I'm still compiling for net standard. So one thing I can do now, I can say I want to compile for netcore app 3.0 or 3.1, let's say. Doesn't really matter for our case. Or does it? I actually don't remember when we did it in, we might have done it in 3.1 actually. Doesn't matter. But now the warning disappears because this guy here, if we actually go to definition, it has this attribute here that says does not return if. So basically what it says is if this condition here is false, this guy will never return. And that's how the compiler knows that if this thing is in front of it, that it can safely assert that this operator here is guaranteed to not be null. And so if you want to still target net standard, well, then what you would do is you would define your own assert method, you know, Minsk debug assert or Minsk assert or whatever, right? And then I would put that attribute on that guy and use this assert method as opposed to the regular one. But for all purposes here, just retargeting to net core app is something I wanted to do anyways. So here we go. Why don't you initialize the symbol dictionary in the constructor of bound scope? The reason I didn't do that is because this is lazy, right? So you have a lot of scopes in your language usually. When you know, every time you have curly braces, there's a scope. But for the most part, you don't actually need to store any symbols because, well, we don't declare literally symbols in every layer, right? And dictionaries are not super lightweight. So what I basically do is just say, well, I only initialize symbols when you actually declare anything, right? So basically the things are done here, right? I have a null check here, and if the symbols are not declared yet, then I actually initialize it. And then look up, I say, well, if I don't have any, then I know I don't have any, right? So this is a lazy initialization pattern, which is actually fairly common in code, right? All right, so now this guy here says, well, you don't allow to pass in null. So let's go over our type definitions here and check what we have. So we guaranteed a start and an end block. We have a bunch of blocks and we have a bunch of branches. That looks reasonable. Okay, our basic block, start, statements, incoming, outgoing. That makes sense. Basic block branch from to with a condition. The condition is indeed optional. Okay, for block builder, statements, blocks, build. That seems fine. Graph builder. Bunch of stuff happens here. Yeah, that seems reasonable. So I think that one is done as well. So I think now the only case of one is our binder, I hope. No, the no printer is complaining. So here's an example of what I said earlier, where our base type, you know, object or toString is typed as return nullable because we don't know what we call it on. So that means value here is considered nullable. But as I said earlier, like I know for a fact that, you know, when value is not null, then toString will always be defined because you only have primitives for the value, right? There's no other reference types we have in there. So what I can do is I can just say treat for all intents and purposes, treat this as not null. And then this thing will shut up. All right, so now the only place we have is the binder with warnings, right? Yes. All right, so now let's walk this chain. Break label, continue label, loop stack. Yeah, that's fine. These are all read only and they're already initialized. All right, so function might be null, I believe, right? Clearly. That means we should mark this as nullable. The scope. Can the scope be null? First of all, can the scope be read only? Probably, right? Because you computed in the constructor. Oopsie. Alright, so it cannot be read only. Apparently we assigned to it in other places, which is interesting. Oh, of course we assign it other places because the scope is just keeping track of nesting. Of course we assign to it. Okay, never mind. All right, so yes, this guy can this guy be null? No, because we will always have a scope. Like at the very top layer, there's always going to be a scope, and its parent might be null, but scope is never null. Okay, so that's fine. Okay, this guy might, sorry, this guy here might be null, the parent. Okay, bind global scope. Previous might be null. We do have syntax trees. Yeah, usually my flow, I don't look at code yet. I usually start with signatures because then that minimizes the number of times I have to walk back and forth between code and non-code parts. I found that to be quite usable. Okay, bound program is previous, and then bound global scope, global scope. That makes sense. All right, and from here on we go. Okay, this guy is nullable. As I said, this guy is always going to be initialized, so that's fine. And then all our bind statements, I don't think any of them return null ever, because they will always manufacture something. Except for the type 1. I can't believe that. Alright, so then let's start with the, I guess at this point it's just easier to just actually walk the code. It's funny how you say this is what I do, and then it turns out that's actually not what you do. Alright, so let's go over the binder. Here we go. Alright, so what is this? Main function might be null. Yes, these guys should be declared as nullable. Report main must have correct signatures. Main function declaration identifier. So that's a prime example where the compiler can possibly know that certain things are not null. So how do we construct this guy? Where does this guy come from? Right, so we have bound them. So in this case, we know the declaration is not null because we selected it from an array. And the array itself is something that we created here, which is we said we asked for the declared functions. So the declared functions all have a declaration by definition. So in this case, I can bang this guy away here because I know this guy is not going to be null. Yeah, that's the same here. So given that we get this function from the global scope, which is the declared functions, we know that this guy is always defined. Okay, so bind type clause, this guy is allowed to be null. But the flip side is we might also give you null. Yeah, so this is one of the examples where a custom annotation will be helpful. Which I guess is something like not null if not null or something to that extent. which basically says if you give us null, I give you null, I believe. Oh, okay, fine, be like that. What is now going on? Yeah, this is one of those examples where even though I've worked on it, I can never remember the combination of things. So let's just go to the documentation. So there's various attributes. I think this one is actually not for the output, it's for other so this is basically allow null, this allow null, maybe null, not null. And null waiting for argument, maybe null when the method returns a specified bool. Yeah, this is the one I want to think, right? I think there was a blog post somewhere with this guy. I think my buddy Philip wrote about it. That's unfortunate. So what's the problem here? Attribute not null if not null is not valid on this declaration type. It's only valid on property, index, parameter, return declarations. Oh, I see. Fine, be like that. It's on the return. So I think this one should have solved our issues here. I believe. Well, hopefully people understand what this guy does, right? Bind type clause. Yeah, here's the guy, right? So the compiler knows at this point that this guy is not null because parameters types are required. So it also knows that this guy is not null right now. I mean, it says it's nullable here, but that's IntelliSense being not great. But null inference can infer correctly that this guy is not null here because we said so, which is why it doesn't warn here, right? Because this guy here, even though it's nullable, this guy does not accept a nullable type. So the right things are happening. Function declaration. Yeah, we can either bang it away or we can just say, you know what, we are standing on the syntax here, so functions should always have a declaration, and the built-in should be an undeclared function, and functions should derive from that. I'm not sure how this would help our case though, because even in that world you would have a polymorphic class hierarchy, and if you consume functions via the base type, then the base type would have to. Oh, okay, I see what you're saying. So you're basically saying built-in functions should derive from undeclared function, or should be undeclared functions, and regular functions should derive from undeclared functions, override the, or yeah, I guess not override, basically define the declared syntax. That's actually not a bad idea. We could do that. Would certainly reduce the number of clutter we have. But in my experience, these polymorphic changes are also not free of churn, so something to be considered. So here's one problem where scope is considered non-null. The parent is null, but we know that In our case, this is safe because we set it here and now we just get it back. But you can't express that statically. So bind variable declaration. So this guy clearly is nullable. Yes, same thing here. We know that you don't know this, but we know this. Syntax, expression, location. Yeah, so that's another example where the compiler cannot know that. So this is the bound expression, right? And the bound expression, if the bound expression is not null, then we know for a fact that the underlying syntax expression wasn't null either. But so same here, we check expression is not null. Now it's safe to derive that to access this guy. Same here, we know that expression is not null, so we can do that. All right. Bind variable reference. Okay, this guy can be nullable. And then this guy can also be null. Alright, so that means our binder is now done. Okay, so that means binding is done. Symbols now has warnings. How is that possible? Oh yeah, so when we upgraded from .NET Standard to .NET Core, now we get more annotations for the BCL. And of course, now we get warnings in places that we didn't get before, which is another reason why we generally recommend, if you do still want to ship as net standard, you should multi-target for net standard and net core app, so that you get the additional annotations for the BCL, so that you know that your own annotations are actually not lying. So for example, when we invoke reflection emit here, sorry, not reflection emit, when we invoke reflection APIs, well, get value might return null, right? So, but we say here we return only non-nullable symbols, and that's what this warning here is. It's like saying, yeah, I can convert from enumerable function symbol question mark to enumerable function symbol. And so one thing we could be doing here is we could say where f is not null. Yeah, and I think that's one of those errors where link is not able to express that. So, but we can cheat and we can say cast this to function symbol. Right? So in our case here, again, like we could also lie probably earlier. It's probably, honestly here, it might make more sense to just bang this guy here, because we are literally standing on the type, and we know, of course, for a fact that print input and the other guys are always initialized, right? So that seems like a better fix. All right, so that means symbols are now done. Lowering is the next one. So what's happening here? I see. So that's the same thing here. We of course know statically that we do have a less or equals operator for ints, so we can just bang this guy here. That solves our problem here. And now we're stuck with emit, and emit has, I guess we have errors because we couldn't resolve. So yeah, after you retarget, you should probably run restore again. in Visual Studio, the tooltip actually tells you the result of the static null reference, of the static null inference. It'll tell you variable is not null here, which is nice. I agree. All right, so now we only have warnings here. So what's happening here? Emitter. Type definitions uninitialized. Random field definitions uninitialized. Yep, that is actually correct. Although really is type in, did we not do that? Type, I mean, I completely understand, I completely remember that this guy here can be null. This guy seems weird. Why would that be null? There's always going to be a type. Alright, so resolve type. So this guy can return null. So that means I need to do this. Resolve method. Alright, this guy can be returning null. So let's do that. Required types not found. Alright, so that means this guy here can be null. This guy can be null. So that's funny. So that actually might be a bug now. So basically what ends up happening is when we say, you know, resolve type, we will report an error here, which is all right. But we also return null. So that means, strictly speaking, we do continue compilation, right? So if later if later parts in our compiler are referencing these things, then they might still not ref, right? So even though we reported an error, that does not necessarily mean that we are now guarding guarding correctly, which is now an actually interesting thing. What should I do in this case? So one thing we could be doing is, instead of doing this, we could just say, well, if any of these guys are not defined, so either we can say we move this logic to the consumption side. Instead of reporting the error on import time, we report the error on use time, which would mean that the compiler would generally let you compile things when APIs are missing, unless you use the language feature that requires that member, right? So in other words, if I can't import console readline, that's fine until you actually start calling the input function, right? And that's a perfectly sensible design point. The other option we have is we can say, well, we literally just throw an exception here, but that means the first time you fail to import something, you only report that error and then you terminate, which is not great, because generally speaking, you want to return as many errors as you can before you terminate, so that the developer doesn't have this problem where they fix one issue, they recompile, they get one more error, they recompile again, they fix, and so it's this infinite cycle of having to recompile, and you never know when you're done, right? As opposed to you get 14 errors, and now you see the number shrinking, which is a much better experience for the developer. So we could also just say, screw it, we just declare them all as local variables that are nullable, and we check that if any of them are null, then we terminate. Otherwise, we continue. Which is, I think, what I want to do, because that seems cleaner. Yeah, it's more work for us though. So the other thing we could do is we could say, look, these are all things that are net standard. So what is the chances that somebody would encounter this? Very slim. So We still want to handle that case, but it's totally okay if we just throw an exception here and call it a day. Which seems like a reasonable pattern, actually. So yeah, we can probably cheat here and just reuse an existing inflection API here. Throw new type missing. Is that a thing? Or is it missing type? Missing. Yeah. Fine. Let's be good citizens here, and let's say we have a private sealed missing required member exception. Probably helps to say class. Yeah, fine. And then instead of doing this, we just say throw new this guy, which null means this guy never returns null, and this guy never returns null. And now instead of doing this, we will just say try try this guy here, right? Missing required member exception. I don't think I like the name. I think I probably should go for a different name. Something like yeah. Problem is at this point, what do I do here? There's not much I can do, right? So maybe this code should not be here. Actually, this should probably be at the call side. Because in our case, this guy here is private anyway, so we know that the only party that can construct this guy is here, us. And so we would just say we already reported an error. Yeah, either way. Yeah, that's unfortunate, right? We should probably, and I guess the diagnostics here are private, right? But yeah, we're in the same type, so we can cheat. We can say, actually we can't. Oh, that's unfortunate. If the constructor blows up, we can't even access the diagnostics. That is unfortunate. That is very unfortunate, as it turns out. So that means probably, come to think of this, doing this in the constructor might not be the best way of doing it. Or alternatively, we could say we pass in the diagnostics that are filled in which case I can access that later if it didn't work, which might be cleaner. I mean, it doesn't really change anything because I could probably if I don't assign these guys in the constructor, then the constructor will complain that they all need to be nullable. Yeah. What do we do here? So we could probably say you know what we would say? We will do this differently. We will do the following. We will truthfully return null, but we will bang that here because the way we will deal with that situation is instead of doing this, return null, our design will be as such that we will do, and then we will say emit. So this is exactly, so that's what I was thinking. So emit already doesn't do that. So emit basically says if you have any diagnostics, so this is an instance method, right? So this guy executes after the constructor ran. So if the constructor couldn't resolve a dependency, it already reported an error. So in which case we bail, right? We immediately bail out. So that means we will never have the situation where later parts of the compiler now access a dependency that we don't have, right? So that's already working the way it should. What is this guy here? Oh yeah, okay, fine, be like that. So that is nullable here, of course. And that means for all intents and purposes we can claim these are not null because our construction makes sure that you cannot observe them to be null. So that now begs the question, who is assigning type definition? So where's this coming from? This guy does it, and that is emit. And is there any reason why we do this in emit and not in the constructor? We probably should do this in the constructor, because it seems a bit weird that this guy is nullable, as I said earlier. So that means yeah, assembly definition. So this is all fine, I think. So we take this code here and move that here. And now the only thing we could make sure here is we could say if object type is not null, then do this. Because if it's possible that we couldn't resolve object, right? In which case we would null ref, it's probably, or not null ref, but maybe we get an argument null exception here because we pass in null. So we could just do that. And I probably still get an error here now because it says this guy is not initialized. It is initialized. I guess we should, instead of doing that, we could do that here, right? We could say now we definitely make sure that the thing is initialized, so we no longer get a warning here on this constructor, and the flow is what we would expect. So mid-constant expression. So yes, so we, in this case I'm actually fine with doing an assert here, because that seems, if this is not null here, debug assert node constant value is not null. Otherwise we shouldn't have gotten here in the first place. Clearly this guy can be null. Alright, so that means our emitter is now also green. Now let's go compilation. Cool, we no longer need this one because we removed the code. Don't need this one here. Alright, so this guy can clearly be null. Previous can clearly be null. Main function can be null. Yeah, it helps if you put the question mark in the right place. Alright, so this guy can be null. This looks right. What are the... Oh, this is deletions, not errors. Okay. And then evaluation result. Yes, this guy can be null. Very much so. Which now means that this is all about right. Evaluator. Let me guess, last value is not null. Random is uninitialized. Yes, I think this is lazy as well, and I'm pretty sure that this one can be null. This guy can be null, I suppose. Which now means this guy can be null. Again, debug, assert, and constant value is not null. Yeah, so the call expression can be null, right? Apparently this guy can be null as well. Okay, now that means this guy can be null. Yes, and this is when bad things happen. So in this case, this might actually be the cleanest solution in general. So again, the structure of our binder or our compiler is such that certain combinations can't happen, right? So for example, when you call a method like evaluate call expression, if that is a void function, then the return value is null. But that means this needs to be a top level expression, right? Under a statement. It cannot be nested in another one. Otherwise our compiler had a bug, right? And we allowed something like a plus print, for example, where print returns void. And so in this case, just debug asserting those things makes the most sense. And, 'cause, 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 ' because the compiler can't know that. I guess this should be right is not null. And then call expression. Yeah, this is fine. We know that this guy is not null here because we do a hard cast anyway. So I guess this is probably what we need to do. Yeah, so that seems fine. I guess these are local variables, right? They can in principle be null. And then locals push locals. I guess that's fine. So let's go here. This guy needs to be nullable. Or does it actually? No, it does not, because we don't allow null values yet for our own variables. So that means same thing here. We should be able to say debug assert value is not null. And of course, this is value is not null. It's the same concept here. Debug assert value is not null. And then same here, we do a hard cast, so we might as well bang away the nullness. Alright, so that means everything is now without warnings except this guy here, right? I guess that's fair. I really wish there would be a swap refactoring here. Seems like a common thing at least. Alright, so now what else do we need to do? Here we go. I think it's the same concept as here, right? We're basically saying, give me the text. And then, do we have this punctuation? I don't think we do, right? We do not. Good enough then. Alright, so now we should no longer get any warnings in Minsk. There's a lot of banging going on. No wonder I got a mature audience only warning when starting the stream. Yeah, so Frederick was saying, screw the emitter, it's ugly anyway, and probably need meta refactoring just to disable nullable here and continue. Yeah, sometimes that's the right approach, but I don't know how you learn, but the way I learn usually is that I need to do things incrementally. And that usually for me means I have to like visit things a few times before I even know what the correct answer is. And the nice thing with nullable is that it kind of forces you to think about your data flow in your program, right? You see how information is flowing, and it does a good job of effectively second guessing. Yeah, basically, like, is your assumption about how your program works actually how the program really works? And sometimes that results in congruency, right? Where you say, okay, that matches my intuition, and sometimes you're like, I didn't know my program was doing that, right? So for example, in my case, I was assuming that I would crash later if, required compiler members were not resolved. And then because the way code was structured, it turns out, no, that's not actually the case. So, and kind of, even if that means, oh, you don't have to do anything, your code already is correct, you still learn something about your code, and you would have avoided doing some crazy refactorings, right? So I think generally speaking, I would probably encourage people not to do what Frederick was suggesting. If you actually do nullable, try to avoid basically having black holes in your program. Like, try to walk them all. Even if you bang a few things here and there, I mean, we haven't done that much banging. We have basically just taken a few cases where it's somewhat obvious in the context of the method that things are not there. The emitter is probably the only case where it's not really localized, right? Where it's kind of spreading across several methods. And that's kind of what you should probably avoid. You should make sure that when you bang things, that the amount of context that the caller has to have in order to see whether that is correct should be within the same method, right? If I have to study your entire type design and like, oh yeah, the code flow goes like this and the control flow goes like that, then you're also very likely to break that eventually, right? Even if your use of the bang operator is correct, it doesn't mean that it stays correct when it's spread so far apart, right? So in that sense, I agree with Frederick that the emitter needs work, but I would also say that I don't see this as wasted time, because we learned something by looking at the code. All right, so that now means I think, commit this, which I don't think I'm going to review because there's a lot of stuff that we did, and it's going to be a very messy diff. Made the Minsk project nullable aware. All right, I have 15 minutes left, and I have a meeting at 10, but I have to be. So I think I call this a day. I mean, there's still more for us to do. We can probably do these guys here though, right? That should not be that much work. Probably tests is quite a bit of work. And if I had to guess, these guys are pretty much cheap. That's probably some warnings we get. What is PI here? Okay, we always have a name here. So parameter name can be null. It's legal in IL, but in our case, that's not going to be the case. We know that. State can be null. Yeah, that is correct. Which means you probably have to change the signature here of this guy. So here's another interesting tidbit. Because we have a custom delegate handler here, we can annotate them the way we see fit. If you use a lot of funcs and actions, you might find that they are not sufficient for your nullable annotations. partially because generics are generally hard with nullable annotations, but also because you can't actually put any attributes on the parameters. So we have some cases where you need to tweak the nullable analysis by putting attributes on the parameters, which you can't do when you have generic funcs, right? If you have your own delegate type like we do here, well, it's fine. You just add a freaking attribute wherever you want, right? So that's a downside with the way nullables are expressed, that it doesn't gel in all the cases where you would like it to. So keep that in mind in your code base. If you're very func and action heavy, that might be an issue. What? Oh, because the handler is not, I see. So I said the render line method does not match the, yeah, fine, be like that. So the render, no, what is it? The render line method. So this is this guy here. Should also take a nullable state. And then of course it also returns a nullable. Okay, fine. And then we have to go back to our handler here. And also mark this guy as nullable. Alright, so now made MSC project nullable aware. Yeah, probably not. Probably would have helped if you would have actually added the source files as well. So this is the compiler here. Yeah, this is the actual change, and then this guy is just MSI, alright. Made MSI project nullable aware. Yeah, if I could spell. Yeah. Here we go. This is what we did today. Good enough, I would say. For the next time, I think generators and Minsk tests are in order, but that should be not that much work. And then we can do some minor cleanup where we effectively move the nullable property to the directory.build.props. Because it now means if we create new projects, they're also by default non-nullable enabled, right? So if you never use directory.build.props and directory.build.targets, you should, because they allow you to centralize settings across all your projects. And they're just generally amazing things. And they work in Visual Studio as well as on the command line, which also is really nice because it means you have, symmetry on your builds and everything is awesome. All right, so are there any more questions in chat? Otherwise, I would kind of call it a day. That shouldn't be too much work 2 hours later. Yeah, it's not that bad. I mean, we just did the 2 projects with very little amount of code in it. Still somewhat concerned that there is a change in here that we haven't committed. Oh, there's a warning in here that we didn't commit. How did that happen? Previous is uninitialized. Create script. Really, you don't take null? You don't take null, that's correct. Ay. Okay, this one we need to fix now. This is what happens when you think you're done. So this is the compiler, right? So this is Minsk. All right, so let me do this. Fix Minsk. And then this is fix MSI. Rebase master. Fix MSI, all right. So what? They're not to fix. Apparently I forgot to say fix. Alright. Alright, same statement happens. This is what we did today. But now it's actually building. Well, let me at least make sure it's building. But yeah. Any more questions? All right, now I get a green build. Okay, fine. Show you my screen. No warnings, no errors. Hopefully no test breaks. If I now have test breaks, I'm screwed. No test breaks either. Okay, let me just quickly create the PR. In draft mode, of course. And then this would be episode 25, nullable reference types. All right. So I said I called it a day, now 4 times. But like, yeah. Martek fan is asking what's next. So I think the next thing I want to do is I want to finish nullable annotations for the other projects. And then afterwards, probably we still have time because I don't think it will take 2 hours. I will also fix the generator because right now the generator does not actually honor our nullable annotations, which I think will be interesting because right now we annotate our source code, but with the generator we also will see what consuming these annotations will look like from the Roslyn side. And then we will have a generator that actually makes sure that when we walk our syntax nodes that we don't return null nodes, because currently we do return null nodes, which is actually a bug that we need to fix. But I didn't want to blindly put null checks on all the nodes, so I decided not to fix the bug until we have nullable annotations in the syntax trees, and now we can actually use that as well. All right, so this is it for today. I wish you guys all a great weekend and enjoy whatever you're doing, and yeah, keep submitting the PRs, and I will promise by next time I will have read all the ones that are submitted, and then I think we can make a decision where we want to move things forward to. All right, bye-bye, and I see you next week.